Thanks for joining us. My name is Jed Johnson, Chief Pilot for Pilatus Business Aircraft. We're here today with the Pilatus PC-12 NG, and over the next few minutes we'd like to give you an overview of our avionics suite, the Honeywell Primus Apex system. We're confident as you learn more, you'll agree just how feature-rich, well-integrated, and easy to use this system is.
All right, Honeywell's Primus Apex system in the PC-12 is laid out with a 4-screen format, which gives you the benefit of having all the information that you really need to look at in front of each pilot location. You've got the primary flight display, the engine instruments on both sides of the cockpit, as well as the nav and comm frequencies right in front of the pilot in the field of view that you're going to see most of the time. In the center, we've got 2 multifunction displays. The upper one in this configuration is set up to be an interactive INAV system, which is a moving map as well as all your flight planning information. The lower MFD is set up to show in this configuration the systems page, which includes all the electrical, fuel, pressurization, trims, flaps, gear, so forth, as well as a crew alerting system, which scales the caution and warning messages in the need-to-know format as far as the most important to the least important. In the PC-12, we've got 2 redundant ways to interact with the Apex system. One of them is the alphanumeric keypad that contains a joystick, and a fully redundant way is the cursor control device, which we generally use in flight. It basically is right where your hand falls when you're in the cockpit. What we'd like to do here is just quickly load a flight plan from here at Denver's Metro Airport up to Aspen, for example. If you notice, it already has the current position, so this system has auto-initialized itself. And as we click to the airplane on the ground, if you see the symbols in our little flight management window here, it walks you through the things that it wants you to do. So it already knows where we are. It knows we're at Denver's Metro Airport, and we'll type in KASE for Aspen, and we'll insert that into the flight plan. And really, if we didn't have any other features to our flight plan, we could just hit activate and we'd be done. If we want to add a departure, which we'd probably get, we could put in the runway that we're going to be using, and we'll fly the Rockies departure up to Red Table. And these are all in here alphanumerically, so they're easy to find. And we just hit activate. And if you notice over here on the multifunction window, it's actually drawn that in there, and it shows us exactly what our flight plan looks like before we use it. And if you can see over here, it's jumped to the next thing it wants us to do, which is to put in our cruise altitude. So this example, we'll use flight level 240. And then it goes right to the fuel and the weight. It knows the aircraft's operating weight. It takes the fuel out of the fuel system on the aircraft. We're going to say, for example, 2 passengers at 200 pounds and 50 pounds of baggage. We don't have to put this information in here, but if we do, it's going to give us the benefit of deriving some performance data in our flight plan, such as top of climb and top of descent. There it's computed the data. We look at our waypoints here, and we actually have top of climb, top of descent, our destination, as well as a discontinuity here, which lets us have an opportunity to put an approach in there. Now, the one thing I neglected to do was to put in an alternate. So if we want to go back and put an alternate in, we can just go to the airplane on the ground, type in an alternate, KRIL, and the benefit of that is that we're always going to have fuel remaining at our destination as well as our alternate. Within Apex, one of the great features is that because it's an interactive map, we can simply hover our cursor over an item, and you'll see the blue box outlines it. That's called a focus window. And we can press the enter key, and it's going to give us a list of things we can actually do with that. So we can, for example, in this window, show more info about that. We can bring up information about the runways, airport notes, hotels, ground transportation, etc. But we can also bring up the frequencies, and we can drop those by just selecting which comm we want it to go to, and it'll drop it right into the standby. So all your frequencies are shown here. Makes it very easy and quick to get to the information you need. And most importantly, there's less heads down time in there, fumbling through charts or trying to get the information off the map itself. We can do the same thing by clicking right over the top of the image. It really doesn't get much simpler than starting the PC-12. Once we've got the batteries turned on, we simply depress the starter button. And the Pilatus Engineering and the Honeywell Apex system produces a semi-automated starting sequence. You see the starter come on, ignition. Once we get enough NG, we introduce fuel. And the system's going to turn off the starter, igniters, and fuel pumps, and then turn on the generators, avionics buses, and the bleed air. An extremely valuable feature incorporated into the PC-12 through Apex is a monitoring system that looks at the parameters required for takeoff. For this example, we've got the flap set at 15, it's in the green. The trims are all in the green, so they're set in the takeoff range. And we have a takeoff configuration CAS message, or crew alerting system message. And that's basically telling us that all the parameters required for safely taking off are not met. In this case, all we have to do is advance the condition lever, which is one of the other monitored systems, and that goes away. If we don't do that, we'll get a no takeoff warning on the primary flight display and an oral warning. To give you an example of here, we come up towards takeoff power.
No takeoff.
We're climbing on a steamboat up to 15.5. And just a quick tour of the primary flight display. We've got our altimeter and airspeed, of course. This red line is the low speed awareness. That's actually where the stick shaker is going to go off and go into the pusher mode. Here we see this little symbol there is the dynamic speed bug. That's given us 1.3 times the stall speed, or that'd be our approach speed if we were in a landing configuration. Right on the inside of the flight path indicator, you'll see a chevron. That's our acceleration chevron. It tells us if we're accelerating or decelerating. It also tells us the flight path angle we can fly at a constant airspeed. Beneath that, you'll see the flight path director. Now, we're flying path instead of pitch, so if we look up here, you can see that the pitch of the aircraft is actually about 10 degrees up, and we're flying just under a 5-degree path. So again, we're looking at where we're going as opposed to where we're pointing. One of the excellent features contained in Apex is we're able to create holding patterns other than ones that are just published. So for example, if we wanted to take a little time here to set up for the approach or wait for weather, we could just select the aircraft symbol there. We'll do present position hold. We can modify this to whatever kind of track we want over this particular point. Press apply, and we're now in a holding pattern. When we're finished with it, we just press exit hold, and it will continue down the path here. So let's say we wanted to hold on this initial fix for the approach. We can create a hold there as well. It's going to just kind of guesstimate the inbounds. We can apply that. So at that point, we can exit this hold. It'll fly down this path and enter that hold there. All right, so as we're looking out the front of the aircraft, you can see the flight path indicator and the zero path line are below this piece of terrain in front of us. So as we stabilize on the speed, if you look at the acceleration chevron right here, that's telling us two things. It's one, telling us we're slightly accelerating, but it's also telling us at the current speed, the angle that we can actually fly. So if we add power, that chevron's going to go up, and we can fly a higher path. So I'm going to add power. Now if you see that chevron goes above the terrain, so if I maintain the speed and pull up, you see the flight path indicator goes up next to the acceleration chevron, and it's over the top of the terrain, which means, one, we're going to be able to maintain our speed on this path angle, and we're going to clear that terrain that's now descending below the path of the airplane. Because we've got 4 screens available and none of the actual mechanisms for the aircraft navigation or communication are contained in those screens, if we were to lose a screen and it goes into reversionary mode, we lose no functionality on the aircraft, and the airplane will simply reconfigure to the next most logical display. I'm going to turn off the pilot's display, and it's now put my primary flight display in the top center screen. If you notice, the autopilot's still on. It hasn't disconnected. We haven't got ourselves into any kind of situation where we've got to react quickly. And then we can simply swap the MFD to show the map down here, or we can go back to the systems page. We still are able to see charts. We can still see our XM image, and it hasn't had to compress really any information except for the systems information when we're looking at the chart. All right, so we failed one screen. What happens if another one quits? So let's turn off this upper MFD. Now the airplane again is going to reconfigure to adjust for what the pilot sees. So our primary flight display is now down here, and it has compressed some information. We've got the systems page over there, and we've got some of the other information compressed into the screen. So if we go to chart video, again, we can still have a chart. We still have our systems page, and we still have enough information to look at the full graphical weather on the airplane. So there's the chart. If we do an MFD swap, there again is our moving map display with XM. All right, so we've got the cockpit set up here for an approach back into Denver's Metro Airport. And again, one of the big advantages of having 4 screens and the extra real estate that entails is we're able to display everything you'd want to see at the same time. Over on my side, I've got the ship's radar. So that's the onboard weather radar, and of course the ship's storm scope. On the center screen, we've got a moving map display with our INAV flight plan and XM weather. Over on the co-pilot side, we have the EGPWS, or the terrain warning system. Then I'm able to see a chart here as well. So we can really see everything at the same time. We don't have to make a choice of what's most important at that time. So on that dark, stormy night when you need everything, everything's available. Here we've got the aircraft in heading mode, which is the traditional way to maneuver around with the autopilot on. Nice thing about Apex is it's got another feature called track mode. So we can actually lay a line right on our MFD, and it'll wind correct itself down this line. So if we're trying to avoid this weather, like in this case, we know the airplane's going to fly right down that line. So again, it just lets us have a little better situational awareness, a little more head-up time, eyeballs out of the cockpit, without having to worry about where the airplane's going and constantly adjusting the heading. All right, so we're descending back into Denver's Metro Airport. We've got the ILS to 29er right tuned in, and it's already auto-tuned this frequency and inbound course into our nav preview window, which is kind of the standby for the next thing the FMS is going to use. If we, for example, got a change of approach, all we got to do is come in here, we click on the arrival runway, we deselect the one we've currently got in there, and we simply select another one. In this case, we'll do vectors to 29er right with the RNAV, and we just reactivate it. And now we've got our new approach in there. We really haven't had to do much. It was about 4 clicks, and it automatically brings up the FMS selected chart as the new chart. So now off in the primary flight display, you've got the cyan image of the runway. You see the final approach course of the breadcrumbs trailing out. So again, the center of the image is where the airplane's actually going, represented by the flight path symbol. Where the airplane's pointed is actually this V over here on the 0 path line. So we know that our nose is pointed to the left relative to where the runway is. So if we were in the clouds doing this approach and we came out, we would expect to look a little bit to the right to find the runway. Now again, notice how stable this picture is. It's not swinging back and forth like you'd see in a heading-based system. So we're stabilized on the final approach, which is represented by the acceleration chevron being basically steady or stable. And we've got the flight path symbol and the flight path director over the runway threshold.
From all of us here at Pilatus, we'd like to thank you for investing the time to learn more about this standout aircraft. Of course, there's no substitute for scheduling some time with the real airplane. We hope you'll take that next step at one of our Pilatus centers, and hopefully in the future we can welcome you to the Pilatus family.